What if the most dangerous decision a human being can ever make wasn't made by a human being at all? What if the order to launch a nuclear weapon, the one decision in human history with the power to end millions of lives in an instant, was handed over to an algorithm? It sounds like science fiction. A rogue AI, a glowing red button, a machine deciding the fate of the world. But strip away the Hollywood drama, and there's a real question underneath it. One that governments, researchers, and defense analysts are actually grappling with right now. Not could a robot start a nuclear war for fun, but something far more uncomfortable. What happens when the most catastrophic decision available to humanity gets faster, more automated, and less human? By the end of this video, you'll understand exactly how nuclear weapons are controlled today, what AI can realistically do in that system, where the real dangers lie, and why almost every serious researcher who studies this topic arrives at the same unsettling conclusion. Let's get into it. First, we need to understand why nuclear weapons are treated differently from every other technology on Earth. When a piece of software fails in your phone, you restart it. When an AI makes a mistake recommending a movie, nobody dies. But nuclear weapons don't work like that. A single error in this domain isn't a bug, it's potentially mass casualties, long-term environmental devastation, and a chain reaction of escalation that cannot be undone. There is no undo button for a nuclear detonation. That's why when researchers study AI and nuclear weapons, they're not really asking, is AI fast enough or is AI smart enough? They're asking something much harder. Can AI be trusted when it's being deceived, when it's under attack, when the data it receives is incomplete, corrupted, or deliberately falsified? Speed doesn't matter if the machine is confidently wrong. So let's start with how nuclear control actually works today, before any AI gets involved. Modern nuclear powers run what's called nuclear command, control, and communications, usually shortened to NC3. Think of NC3 as the nervous system of a nuclear arsenal. Its job is threefold: detect potential threats, like an incoming missile, move that information up the chain of command as fast as possible, and make absolutely sure that any launch order is authenticated and securely transmitted. So a fake or unauthorized command can never slip through. In theory, this system exists specifically to reduce confusion and prevent accidents. It's layered, redundant, and built around one core idea: humans, not machines, make the final call. And that human role isn't just procedural, it's actually central to how these decisions function. A nuclear launch decision isn't just about raw data, it's about judging intent. Is this actually an attack or a false alarm? It's about judging credibility. Is this threat real, or is someone trying to provoke a reaction? It's about timing and about weighing consequences that go far beyond the battlefield. Political consequences, diplomatic consequences, generational consequences. Here's the key distinction. AI can process information, it cannot understand politics, it cannot understand deterrence theory, and it absolutely cannot carry the moral weight of a decision to end human lives on a massive scale. That's not a technical limitation that better engineering fixes next year. It's a fundamental difference between calculation and judgment. So if full AI control sounds dangerous, and it is, what's actually realistic? What are AI systems being explored for in the nuclear context right now? According to research from the Nuclear Threat Initiative and the Stockholm International Peace Research Institute, the realistic near-term role for AI isn't replacement, it's support. AI can help process huge volumes of sensor data faster than humans can. It can improve communication systems, it can assist intelligence analysts by spotting unusual patterns buried inside oceans of information that would take a human team days to sort through manually. On the surface, that sounds genuinely useful, and in some cases it might be. Faster data processing could mean catching a real threat sooner. But here's the uncomfortable twist that most people miss. In a nuclear crisis, faster is not automatically better. If AI speeds up how quickly information moves, it also speeds up how quickly pressure builds. It can shrink the amount of time human leaders have to stop, think, question the data, and ask, wait, are we sure about this? Compressing that decision window doesn't just save time, it removes the single most valuable resource in a nuclear crisis, which is the time for human doubt. Now let's go level by level into the real risks, because this is where the picture gets genuinely alarming. Level 1, false confidence. Modern AI systems are extremely good at pattern recognition. That's their core strength. But here's what that strength hides. These systems can also misclassify information, generate confident-sounding but incorrect conclusions, often called hallucinations, and behave unpredictably the moment they're pushed outside the narrow conditions they were trained on. In a normal setting, an AI mistake is an inconvenience. In a nuclear setting, a single mistaken inference, a satellite misreading a weather pattern as a missile launch, for example, could become the spark for catastrophe. And the danger isn't that the AI is malicious, it's that it's wrong, at exactly the moment when being wrong carries the highest possible cost in human history. Level 2 manipulation. This is, according to the Council on Foreign Relations, one of the most serious emerging risks. We now live in a world with AI-generated misinformation, deepfake videos, falsified audio recordings, and digitally altered satellite imagery. Now imagine any of that being fed into an early warning system or shown to a national leader during a fast-moving crisis. A sophisticated actor wouldn't need to hack a missile system to start a nuclear crisis. They might just need to convincingly fake the data that humans or AI rely on to make decisions. CIPRI's research adds another layer to this: vulnerability to cyber attacks, weak or corrupted data quality, and the simple fact that current AI systems still have real documented limits in reliability. The machine doesn't need evil intent. It just needs to be fed the wrong information at the wrong moment, and it can become the most dangerous link in the entire chain. Level 3. The line between assistance and autonomy. This is the single most important distinction in this entire conversation, so listen closely. There is a massive difference between AI that advises humans and AI that decides whether nuclear weapons are used. A support system, one that flags unusual sensor data or speeds up analysis, can be audited, it can be constrained, it can be overridden by a human at any point. That's a tool fundamentally under human control. But a fully autonomous launch system is something else entirely. It would place the most destructive act in human history into the hands of software that cannot reason morally, cannot negotiate strategically, and cannot understand context the way a human leader can. It cannot ask, does this really make sense, given everything I know about the world? It can only calculate based on what it's been given. This is exactly why the policy world treats this distinction so seriously. The Nuclear Threat Initiative has explicitly stated that automated retaliatory launch systems are highly risky and should be avoided entirely. The European Leadership Network's research on the 5 major nuclear powers recommends building strong risk management frameworks and critically retaining human control over nuclear systems at every stage. The principle that keeps showing up again and again across nearly every major research organization studying this topic is remarkably simple. AI may help humans interpret a complicated and dangerous world, but it should never replace human judgment at the actual moment of launch. Now, let's look at the 2 paths this could realistically take, because this isn't purely a doom story. There's a best case version of this too. In the best case scenario, AI becomes a force multiplier for caution. It improves early warning accuracy, filters out noise and false signals, helps analysts catch real threats faster, and reduces the risk of accidental escalation, all while human beings remain firmly, unambiguously in control of the final decision. In this version, AI is treated exactly the way a powerful tool should be treated, useful but subordinate to human judgment. But there's a worst-case version too, and it's less about robots going rogue and more about human psychology. In the worst-case scenario, leaders simply start trusting AI too much. Human review gets reduced because the AI seems reliable, seems fast, seems confident. Decision-making authority quietly shifts toward machines that are working with partial, corrupted, or manipulated information. And in that world, a false alarm, a cyber attack, or a convincing deepfake doesn't just cause confusion, it could trigger consequences that are impossible to reverse. Notice something important here. The worst case scenario isn't really about AI becoming evil or uncontrollable. It's about humans gradually, quietly handing over more trust than the technology has actually earned. So where does the actual policy conversation stand right now in the real world. Based on recent analysis from the Nuclear Threat Initiative, CPRI, the Council on Foreign Relations, and the European Leadership Network, the direction is clear. Nobody serious is pushing toward a machine-run nuclear arsenal. Every major voice in this space is emphasizing caution, human oversight, and strict limits on integrating high-risk AI into nuclear command systems. That doesn't mean AI has zero role. It means the most dangerous possible use case, machine authority over the actual launch decision, is the exact use case that experts warn against most strongly and most consistently. The more realistic near-term concern isn't a machine pulling the trigger. It's AI quietly influencing intelligence gathering, surveillance interpretation, and the speed at which decisions get made, shaping the environment around the decision, even if a human technically still makes the final call. So let's bring this all together. Handing nuclear control over to AI wouldn't eliminate risk. It would relocate that risk, moving it into software, into sensor networks, into data pipelines and machine learning models that may not be trustworthy under the exact conditions where trust matters most. A crisis with incomplete information and very little time. The core lesson from all of this research points to one consistent idea. Nuclear deterrence has always depended on cautious, deliberate human judgment, especially in moments when information is uncertain and time is short. That's not a flaw in the system. That hesitation, that human instinct to double check, to ask, are we absolutely sure, is actually one of the most important safety features the entire system has. And here's the angle that I think actually matters most, the one that gets lost in the sci-fi version of this conversation. The real danger was never a robot independently deciding to start a nuclear war on its own. That's the dramatic version, the movie version. The real danger is something quieter, and honestly more disturbing. A world where humans start believing that a machine can safely decide whether a war has already begun, where leaders start trusting the readout on a screen more than their own judgment, where the pause to question, to verify, to doubt, the pause that has prevented nuclear war for over 70 years, gets engineered away in the name of speed and efficiency. That is a line that, according to virtually every serious researcher studying this topic, the world should be extremely careful never to cross. If you're curious about other ways AI is reshaping global security beyond just nuclear weapons, let me know in the comments because that's a series I'm seriously considering covering next. Subscribe if you want more deep dives like this one, breaking down the technology that's quietly shaping our future.